In this video, we're going to talk about the different subatomic particles that you learned in previous science courses. We're going to go over the notation system that we use to describe different types of atoms, as well as a special type of atom called an isotope. You are going to need either your notebook or your fill-in notes and something to write with. And once you have those ready, let's go. Okay, so what I have up here is a chart about our different subatomic particles, right? Our proton, our neutron, and our electron. Now, whenever you see these, they always have symbols attached to them, right? So for the proton, the symbol for a proton is P, symbol for a neutron is N, and symbol for electron is E minus, right? So P, N, and E minus are our three symbols. The relative masses of them, protons and neutrons both have a mass of about 1, what we call atomic mass unit. Now this asterisk right here, I gave you the exact value of the atomic mass unit. You're never going to need to know it, right? The entire idea behind me putting this up there is to show you that the atomic mass unit is just a made up unit that we have, which makes our life easier, because instead of working in times 10 to the negative 27th scientific notation, it's just easier to work with whole numbers, isn't it? Right, so relative mass is 1, about 1. Neutron actually is pretty much basically just a proton and electron added together. So it's going to be slightly heavier, but close enough to 1 where we can call it 1. And electrons have a mass that's essentially 0. The reason why we call it 0 is because compared to a proton, it's so light, you need to have like hundreds upon hundreds of them for them to even make the smallest noticeable difference. So we just ignore it, right? And then we also have their charges. Protons are positively charged, electrons are negatively charged, and neutrons, being neutral, have no charge. Right, so those are our three different subatomic particles. Now remember, the nucleus of an atom is what's composed primarily of protons and neutrons, right? We're going to need to know that for what comes up next. So here's how we're going to talk about writing notations for these. Right, so what we have is we're going to have two different numbers we're going to work with. The first number is what's called the atomic number. You're going to see this in diagrams labeled as the variable letter Z. Atomic number is just the number of protons. Right, so all atoms of the same type have the same number of protons. That's the definition. So by definition, every atom of carbon has exactly 6 protons. Every atom of oxygen has exactly 8 protons. That's not going to change. So that's our definition. We have another number that's called the mass number. Again, you'll see this referred to as the variable letter A on diagrams. The mass number is the total mass of the atom's nucleus, which is to say the number of protons and the number of electrons added together. Carbon always has 6 protons, and if you have a carbon atom with exactly 6 neutrons, 6 plus 6 means that atom's nucleus has a mass of 12. One of the ways that we'll write this is we'll write this in what's called isotopic notation, and that looks like this, where you have the symbol for the element that you're using, which in this case they have X. You're going to have the atomic number on the bottom, the mass number on the top. Now, you don't have to be given the atomic number if you're given the symbol, right? If I say carbon, all carbon atoms have 6 protons, so I don't need to tell you that. Right, so for our carbon over here, we have C as our element, 6 protons, and with 6 neutrons gives us a mass number of 12. So that's our symbol for this carbon atom. Now, our special type of atom is what's called an isotope. Because you notice how I said for this carbon atom, it has 6 neutrons? Well, what if the carbon atom didn't have 6 neutrons? Right? What if it had more or less? If it has more or less, you have an isotope, right? So copper, there are 2 types of copper atoms, for example, that exist. Copper that has a mass of 35, and copper that has a mass of 65. Now, because they're copper, they both have the same 29 protons. But what's different about them is the number of neutrons that they have. Whenever you have atoms of the same element with different numbers of neutrons, those are what are called isotopes. So the way that you refer to them is we can either do them through the isotope symbol that we did in the last slide, or we can refer to them by atomic mass name. So we can say copper 63, referring to the 63 atomic mass, or copper 65, referring to the 65 atomic mass. Right, so what I can say, for example, is if I find my cursor, there we go. So if I say, for example, that I have copper, right, copper 29, and I have mass number 63, right, so this is my mass number 63, so the one with 34 neutrons. This is copper 63. That's how we can write it as a name, or this is how we can write it as an isotopic symbol. Either one is acceptable. Use which one you're asked to use in the question, basically. All right, so those are isotopes, and atomic numbers and mass numbers. In a later video, we'll actually get into how to determine the number of protons, neutrons, and electrons that each of these have. But in the next video, we're actually going to talk about what happens if we change the number of electrons instead of the number of neutrons.